Hi everyone, and thank you for having us here today. My name is Donca. I'm a senior architect with Red Hat Services, and with me is my colleague Sylvain Chen. He's a senior principal consultant also with Red Hat Services, and we are here today to quickly discuss the possibilities for moving VMs from Hyper-V to KubeVirt. That said, so let's quickly look at the agenda. So we are going to briefly look at the use case, basically, or the source of this this presentation. We are going to discuss the state of migration tooling, quickly looking at the summary of the migration process and the automation with Ansible. We are going to share some lessons learned on the journey and also a small demo for migration of Windows Server 2022 to KubeVirt. Yes, so let's quickly look at the use case. So this is a real customer use case, right? So they were running the main visualization platform on Hyper-V in multiple bare metal clusters. They experienced some limitations with the existing platform, and they were looking basically to migrate to a more modern solution, a modern visualization platform. They were already running multiple virtualized Kubernetes clusters on top of Hyper-V. So with the familiarity of Kubernetes, so KubeVirt has been an obvious candidate for that. So we started with the customer, and basically we focus on the migration. So we build basically KubeVirt clusters following the same architecture and approach of the customers. So same, let's say, network segmentation and security zones and so on. We had in scope more or less 1,000 VMs, right, to move from Hyper-V to KubeVirt. A large percentage of this being Windows Server 2019 and 2022. Still a very, very, very small amount of Windows Server 2016, and then some Linux workloads, mainly RHEL 8. And then we also had in scope around 70 appliances, which had to be migrated as well from Hyper-V to KubeVirt. These were mainly Cisco ASA, Fortinet appliances, CAN load balancer, and so on. Nonetheless, the customer was also running some kind of client VM, so more or less like a VDI desktop, but with no brokers. So in the Hyper-V, it was mainly Windows 10, and then moving with KubeVirt, it's Windows 11. So they are all going to be redeployed, so no migration in this case. So that said, I will pass it over to Sylvain to give us a little bit of an overview about the state of migration tooling from Hyper-V to KubeVirt.
Thank you, Raresh. So let's have a look at some of the tools. I'll start with Forklift, which is a very nice tool to migrate VMs to KubeVirt. We'll have a look at one of the tools to actually convert the this file from Hyper-V to OVA, and then the potential use case to use a Forklift afterwards. And let's have a look as well at Virt V2V and KMU, which we use in this migration project. So let's start first about Forklift. It's basically a project to orchestrate and validate the migration of VMs. So from, for example, VMware, OVirt, OpenStack, even KubeVirt itself to KubeVirt. It supports some warm migration for some of these hypervisors like VMware, but also can use code migration. So for example, for code migration, it's actually using Virt V2V. And unfortunately, in this project, there was no Hyper-V support, so we couldn't use it. Overall, Forklift is a very nice project with an operator. So we have like new CRDs. We have even a UI to orchestrate and plan the whole migration. In terms of tools that can be interesting is one of the upstream POC that Red Hat Engineering had a look at. Is basically transforming the VHDX files, which are basically Hyper-V specific, into OVA. And OVA format is actually supported by Forklift, so it could be possible in the future, but that was not available anyway for production for our case in our project. So we had a look at the project V2V, which is let's say more than 10 years old, but very suitable for our use case because we have the Hyper-V support to convert the various guests to run on KVM based environment. What is good to know as well is there is no support to connect directly to Hyper-V, so no warm migration is available at this stage. So we had to do a cold migration, meaning we had to shut down the Hyper-V VMs gracefully. So this tool is very useful for, especially for the root disk, because it will install the VRT drivers for both network and block devices. And underneath, it's using KMU IMG for the disk conversion. Here is one example of the use case. So this is a binary. We can use it to transform the VHDX file into QCOW2. And the first boot parameter is very important to actually have additional scripts to do some cleanups, to actually change some network interfaces because maybe in some cases it's not working directly or because of the customer requirements. And on Windows, it's also support the PowerShell scripts to do some cleanup on the Windows registry, for example. And then we have KMU IMG. So we use it mostly for the additional disks. So not just the OS, but just for the data disks. And that's another CLI utility tool that we use in this project for any other additional disks. Same thing here. We have the VHDX files that then get converted into QCOW2 files or RAW. And then we can later on use this via virtcodel. So virtcodel is the main tool to communicate via CLI with KubeVirt to start VMs, but also to upload some of the images here via the CDI, so the containerized data importer, and it can upload that into a data volume, which gets then creates a percent volume claim. Then we can use it later on for the VMs. Another example, we see it in the demo anyway. So let's move to a quick summary before talking about automation. So basically what we are talking about was we need to stop the VM gracefully on the Hyper-V side so that we can start the code migration. Then we have to locate the VHDX file, make the conversion with our tooling. So in this case, we basically install that in the migration node based on Linux. And then we can upload these new converted files into the KubeVirt cluster. Later, it can then be used within the VM. So let's talk about Ansible and the automation, since we don't want to do that manually for each one of these VMs, but instead using Ansible. And it's a great fit, actually, because it can connect to the Hyper-V host, which is Windows bare metal host, and we can connect via WinRM. We can do all of the automation steps, stopping the VM, copying the files, and then connecting to the Linux migration node and execute everything we need. Let's have a look now at the integration, for example, with Windows. On the left side, you can see some of the prerequisites for the Windows servers. It's available on 16, 19, 22, or 25. You need PowerShell, and then you need to activate some parameters to basically activate WinRM. We have some authentication mechanism. And Ansible fits very well because we have like a collection where we can basically use PowerShell scripts, but also copy some various files, and we can connect to Hyper-V that way to get all the metadata and things like that. We also have an integration with KubeVirt. So this is like developed around 2 years ago, and we have 3 modules in one plugin. One is very useful, is the KubeVirt VM module in order to define your YAML file, but also having like some conditionals depending on what kind of VM types it is, either Windows, Windows Server, or Linux, Fedora, Red, and so on, which have like different kind of parameters, and we can start the VM afterwards. Here are some more information if you want to have a look. It's documented at in the Ansible website or directly in the blog post of KubeVirt. Having said that, I would like to hand over back to Raresh, who will give us the overview and as well as talking about the challenges and the lessons learned. Thank you.
Thanks, Sylvain. Okay, so let's have a look at how all of these are coming together. So as we presented, so basically we are using Ansible as an orchestrator. So this could be AWX type of controller, but can also be a plain Linux with Ansible on it. In addition, we are running a migration node, also Linux-based, or it could be as well multiple migration nodes if we want to enable parallel VM migration and so on. So basically, in the first step, we are connecting to the hypervisor directly. So to the Hyper-V hypervisor, we are not using any Microsoft or Windows control systems, so such as the virtual machine managers. So we are connecting directly to the hypervisor, and in this step, we are basically gathering some metadata about the virtual machine. So looking at the CPU, resources, memory, the number of virtual interfaces, the VLANs, which these are attached, right? So all of this information are going to be used later on to have the definition of the VM for KubeVirt target cluster. And then basically in the second step, so we are orchestrating the migration node. So just to prepare the migration, so it's going to copy the disk from the Hyper-V. So this is basically the cold VHDX file, right? So in the first step, we are also gracefully shutting down the VM, which is a prerequisite for the virt-v2v to actually run on that root disk. So basically, we are fetching the disk, then we are running virt-v2v on it. At the end, we are getting a QCOW2 image. In the process, we normally also add a first boot script, so for specific use cases. And once this is done, so we are using vircutl to upload the QCOW image to the target KubeVirt cluster, right? So this is using the CDI importer. And at the end of the process, we are going to get a data volume or a PVC that we are basically we can use for the target VM, right? So this is basically the process for the root disk. If the VM has additional disks, so normally we cannot convert that with virt-v2v. So for this one, we are doing direct conversion with the QMYNG for all the additional disks of the VM, right? Then at the last step, so Ansible is orchestrating basically the target VM on the target KubeVirt cluster. So it's going to define the VM, it's going to bring it up, and it's going to do as well some validations for the respective use case of the VM just before marking it as a successful migration for the VM. Then looking at the next steps, so quickly at the challenges and lessons learned, right? So we've seen basically that for the planning of the migrations and all the activities as well to estimate the level of effort required and potential support from additional teams, it's really good to categorize the VMs into categories. So things like easy, medium, hard. So for example, easy could be systems which are Linux-based system, medium, Windows 2022, a hard something like running Microsoft SQL always on cluster on it and so on, right? Then potentially it's not a surprise for people here, but yeah, the network adapter is changing when we are moving from Hyper-V to KubeVirt. So this is true for both Windows and Linux workloads, right? So there are different solutions for this use case, but basically what we did is using the first boot script to just to make sure that we have the right interface there. That we are going to have network connectivity and so on, especially as we had a lot of VMs with the static IP configuration. Then regarding the storage, so we use the customer fiber channel storage, right, with the respective CSI driver, which worked quite well. We still have some small challenges. For example, the TPM devices, they are creating a very small PVC, right? In our case, it was too small for the storage vendor to create a LAN actually on their storage backend. So we had to adopt with some annotations on the storage class and increase this minimum size. And it's working well, but yeah, we have some concerns about the potential limitation on the storage vendor from the number of LANs which are exposed basically per fiber channel adapter or for a group of hosts, right? So for example, for a KubeVirt cluster, especially because of the architecture of the customer Windows virtual machine. So normally we are consuming 4 to 5, in some cases 6 PVC or 6 LANs for a Windows system there, right? Yeah, then we also seen that, for example, Wi-Fi driver has a limitation, right? So it's defaulting to box driver, but it's not really an issue. We basically avoid migrating any direct loan system, so everything has been migrated with the respective application tool, so we avoided that. And then in terms of appliances, right, so yeah, we've seen that basically it's important to connect with the vendors early on, so that they are basically adding documentation to run these appliances on KubeVirt and potentially as well certified, right? And in general, we recommend it to have the approach basically of a clean appliance installation and do the backup restore of the respective vendor on the new system. But for some use cases, we had to migrate the appliances and it worked well, except the fact that we are not able to use, for most of these use cases, the VirtIO driver. So we are limited with the E1000 network interface card. Good. So then let's quickly look at some references. So basically we documented here some of the internets of interest for this topic. You can find them here, and we can quickly move to a small demo of migrating Windows Server 2022 from Hyper-V to KubeVirt. So basically, we see the VM here. It's a VM which has a static IP address, internet connection, internet is reachable. Then we are running a small playbook to just gather the metadata and shut off the VM. We see the VM is off. We are basically copying the VHDX file to the migration node. We see the information about this respective VM. Then we run the conversion with VirtV2V. Once this is done, we upload it to the CDI proxy. At the end, we are going to have basically the data volume and the PVC. That's the VM definition that has been used here. And we see the VM is basically starting. We can go to the KubeVirt manager and see that the VM is available. So normally we've seen it's rebooting 2 or 3 times after migration, right? But at the end, we also have the system reachable. Good, so that's it. Thank you very much for your time. And if you have any questions, let us know. And you can also reach out to us on LinkedIn. Thank you.
We'll have to stop there because we're at time. There was a question in the chat. You're welcome to answer it in the chat.
Yeah.
Thank you very much for that. That was a crazy turbo demo.
Yeah.
And the demo did have, there's a message chat here, KubeVirt Manager, and there is a talk on KubeVirt Manager, and I think 20 minutes or 40 minutes something. It's coming up.